Look up at the night sky. What do you see? Stars. So many stars. Each one is a sun, maybe far away. Our universe is vast, full of mysteries. It calls to us. Humans have always wondered about what's out there. Space is bigger than you can think. Billions of galaxies float within it. Each galaxy holds billions of stars. Our sun is just one of them, a pretty average star, really, but special to us. It gives us light and warmth. It holds our Earth in its family, a family of planets. But are we alone? Are there other planets orbiting other stars? Yes, we call them exoplanets. Exo means outside, planets outside our solar system. Astronomers have found thousands, so many new worlds to explore. Each one is a new dot of light. Some exoplanets are strange, stranger than anything in science fiction. Hot Jupiters orbiting close to their stars, water worlds covered in deep oceans, and some are truly super, like the one we will talk about. A planet with rings so big, they make Saturn look tiny. Get ready to be amazed. Let's travel far from Earth, about 434 light-years away, to a young star. Its name is V1400 Centauri. Around this star, something amazing orbits. It's called J1407b. Not a catchy name, I know, but what it is incredible. Scientists call it Super Saturn. What makes J1407b so super? Its rings. Oh, those rings, they are absolutely gigantic. The biggest ring system ever found. Imagine a hula hoop, a really, really big hula hoop, around a very big planet, or maybe a small, dim star. Scientists are still figuring that out. How did we find J1407b? It was a bit like hide and seek. Astronomers watched its star. They saw the star's light dim, not just once, but many times. Over 56 days in 2007, something big was passing in front, something with many parts. Those parts were the rings. J1407b itself is massive, much bigger than Jupiter, maybe 10 to 40 times Jupiter's mass. That's a really big boy. It could be a giant planet, or it could be a brown dwarf. A brown dwarf is like a failed star, bigger than a planet, smaller than a star. You know Saturn, right? The jewel of our solar system. Its beautiful rings are famous, made of ice and rock particles, shining brightly in the sunlight. They stretch out far, about 282,000 kilometers wide. That sounds like a lot, but wait until you hear about J1407b. J1407b's rings are truly colossal. They are about 200 times wider than Saturn's rings. Think about that for a moment. 200 Saturn ring systems, lined up side by side. That's how big J1407b's rings are. They stretch out about 120 million kilometers. That's almost the distance from Earth to the Sun. Imagine looking up from J1407b. If you could stand on it, the rings would dominate your sky, a breathtaking giant structure, much brighter and bigger than our moon. They would block out starlight. They would cast huge shadows, a truly alien sky, unlike anything we have ever seen. And these rings are not simple. They have gaps in them. Over 30 distinct rings make up the system. These gaps might mean something. Moons could be forming there, sweeping paths clear of dust and ice, like little shepherd moons, carving out their own orbits, new worlds being born in the rings. Section 4. Spotting Super Saturn, our cosmic detectives. So, how do we see these faraway worlds? We can't just fly there, not yet. We use giant telescopes, our eyes on the universe. Some are on high mountains peering through Earth's atmosphere. Others are in space, floating above the clouds, giving us even clearer views. The Hubble Space Telescope is a hero. It has been observing space for decades, since its launch in 1990. It has shown us distant galaxies, exploding stars and exoplanets. Hubble has helped us understand so much. It has captured images of cotton candy clouds. These are low-density exoplanets. Hubble keeps making discoveries. Then there's the James Webb Space Telescope. JWST is the new kid on the block, but it's incredibly powerful. It sees in infrared light. This light can pass through dust clouds, allowing us to see hidden things. JWST can study exoplanet atmospheres, looking for signs of water or other molecules. It's already finding amazing things like water ice around young stars. Other missions help too. ESA's Gaia mission maps our galaxy. It measures the positions of billions of stars. This helps us find stars that might host planets. NASA's SphereX mission is surveying the whole sky. It will create a huge catalogue of stars. All these tools work together, like cosmic detectives, solving the mysteries of the universe. Section 5. Why we hunt for worlds like J1407b. Why do we spend so much time and so much effort looking for planets like J1407b? It's because we are curious. Humans are explorers by nature. We want to know what's out there. We want to understand the universe and our place within it. It's a fundamental human quest. J1407b is a cosmic laboratory. It teaches us about how planets form, especially giant planets and their moons. How can such a massive ring system exist? How did it get there? How long will it last? These are big questions. Studying J1407b helps us find answers. It pushes our theories to their limits. This giant ringed world shows us that solar systems can be very different. Our solar system is not the only model. The universe is incredibly diverse, full of strange and wonderful things. Finding these extreme examples helps us understand the range of possibilities. From tiny, rocky worlds to giants like J1407b, every exoplanet we find is a piece of a puzzle. The puzzle of how stars and planets are born, how they evolve over billions of years. J1407b is a particularly interesting piece. It represents a young system, perhaps showing us a snapshot of what our own solar system might have looked like long ago when it was young and chaotic. Section 6. Unlocking Planetary Secrets. The lessons from J1407b. J1407b is more than just big rings. It's a dynamic, evolving system. Those rings are probably not permanent. They might disappear over millions of years. The material could form moons or be blown away by starlight. We are seeing it at a special time. Scientists study J1407b carefully. Its rings change the star's light. This pattern reveals the ring's thickness and density. By studying this young system, we learn about early planetary lives. J1407b's star is only 16 million years old. So J1407b is like a planetary toddler, still figuring itself out. This information helps us build better models of planetary systems. Understanding J1407b helps us understand our own Earth and the cosmos. Section 7. The future of exoplanet exploration, more wonders await. The discovery of J1407b is just one step on a long journey of exploration. There are billions of stars in our Milky Way galaxy, and there are billions of other galaxies. Imagine how many planets are out there, waiting to be found. We have only scratched the surface. The cosmic ocean is vast and full of hidden treasures. Future telescopes will be even more amazing. Bigger, more sensitive, more powerful. They will be able to see fainter objects and study them in greater detail. We might find planets like Earth, with atmospheres, with oceans, maybe even with signs of life. That would be a profound discovery, changing how we see ourselves. J1407b reminds us of something important. The universe is full of surprises. It constantly challenges our expectations. It shows us things we never imagined. That's the beauty of science, the thrill of discovery. There is always something new to learn, something wonderful to find. The universe is the ultimate adventure. So, keep looking up at the stars. Keep asking questions. Support the scientists and engineers who build these amazing machines, who dedicate their lives to exploring. The cosmos is not just out there. It is part of us. We are made of stardust. And the quest to understand it is a quest to understand ourselves. If you enjoyed this journey through the cosmos, please subscribe to our channel and like this video. Your support helps us bring you more amazing content. And don't forget to hit that bell so you'll never miss out when I upload new content. Thanks for watching. I'll see you in the next video. Copyright 2025. Mallory Hope Carrington trademark, all rights reserved.